Hello everyone. Let's kick things off by talking about the D2M Android application, how we have been working on it. We have wrapped the MVP 1.0 and the baseline Android application development is complete. To give you a clearer picture, I have mirrored my phone on the screen so you can follow along. The D2M application is ATSC 3.0 compatible, supports multiple receivers globally. The channel scan was successful and now we are on the app's home screen. We have speed up the auto scan tune time so that channel scanning is now faster and smoother. As you can see, we have an EPG for the POC Plus channels. This is something that was not available in our current satellite infrastructure. The EPG info is multilingual, supporting both English and Hindi for one city trial channels. We have streamlined the D2M app setup process for tuning and scanning. It involves faster channel switching, and to make life easier for development and field related activities, we have added options for PCAP replay and SRT link. This is especially useful for those of you working on business development and field trials. From EPG, we can select the channels. We have also made significant improvements in AV playback, especially in terms of supported functionality according to the standard. This includes supports for AQI in MMT thanks to our work with middleware and libTSC3 team. The app also now supports auto rotation, which you can see on the screen. It rotates smoothly based on the device rotation. Currently I have rotated the device in clockwise direction, but the same can be done in the anti-clockwise direction and the device will have a smooth rotation based on the device orientation. We have also added advanced RF parameters. The RF params are for our initial rollout of the D2M One City project. In the RF parameters, we have debug info like RSSI, SNR, TEF, TFC, and I have already mentioned that we now supports playback of ATSC 3.0 SRT and PCAP links. Currently, we are transmitting AV audio only and NRT channels. So services in these sessions are 3 AV services, 3 audio only service and 1 NRT service. Advanced Emergency Alert. AEA is another critical use case that we have been focusing on. Our implementation of emergency alert is more advanced and refined compared to others. We have added support for rich media content, that is images and video delivery over broadcast, and the alerts are presented to the user based on their effective time. So the alerts can be scheduled from a broadcast station and presented to the user again based on the set time from the broadcast station. The alert sound and vibration settings are prioritized according to the alert's importance, even overriding the device silent or mute settings. Now I am going to demonstrate some scenarios of receiving advanced emergency alert. Scenario 1. When the application is in foreground, we will send an alert that has rich media and a text. So the alert, because it is of a high priority, it will autoplay the video after few seconds. Now I will send the alert. Now the alert video message playback is complete. This alert also has a text information, so the user can go through that in a very simple way. Right now on the right side I have a block diagram of our alerts and how these are like sent or delivered over broadcast. As you can see, we have alert automation setup and they are parallelly linked to our NDMA, which is a disaster management government body. These alerts are then sent to cloud, and from cloud they are sent to a broadcast station. From broadcast station they can be received on the ATSC 3.0 receivers. Now let's look at the alert scenario 2, where the application is in background, alert with rich media will come and the alerts are delivered as a notification. You can hear the sound of the alert and the device also vibrates. On clicking the notification, the alert video, again because if it is high priority, it will autoplay. Scenario 3, where the application is in foreground but we send some informational alert which is not of high priority. Alert of this type are delivered to the device without interrupting the app experience. So they are just delivered silently as a notification. On click of the notification, the alert can be accessed. As you can see, the priority of this alert is minor. It is the lowest priority. Now for alerts we have a dedicated alert list which shows the list of active alerts. It is a unified window for all alerts and public messages. The idea behind this is to create a unified interface that serves the purpose not just of emergency alerts but also of various government departments to deliver crucial and important information to the users over broadcast. Use case user statistics. Now let's talk about user statistics, something that is really key in our D2M project. Since the primary device is a mobile phone, a very personal device, it holds a lot of information about the user. We have built a user statistics collection module into our D2M application. The module gathers user entered data such as name, age, interested genre, app uses data such as device type, location, viewing data. The data is collected and stored in background regardless of internet availability, and it is synced to the cloud as soon as internet connection is available. We are collecting detailed data like service view, duration of view, ads viewed, and the percentage of advertisement watched. This helps us create a unique profile for each user, which is incredibly valuable for targeted dynamic ad insertion. Now I have the block diagram of categories of data that we are collecting. It involves user details, RF statistics, and service program usage. These are then synced to the cloud and presented in a refined form on a live dashboard. This information will help us and our D2M partners gain more insight into demographics by age, location, and interest. We have got a test dashboard to showcase this. As you can see, I have mirrored my phone again. I will now show the voluntary details in the application for user profile. From the application settings, the user can enter his generic information like name, email, age, interested genre, and languages, which will be further later used in terms of deciding which dynamic ad should be selected or presented to the user. We have got a test dashboard to demonstrate all the collected user statistics in a refined form. On this developing dashboard, you can see things like the number of live users, the total number of live channels, and the total number of transmission sides. This dashboard has components like demographic distribution of registered user in terms of age. Now I have turned my Wi-Fi on and the user statistic will be immediately start being pushed to the cloud. The dashboard also contains service watch trend and the viewership changes every 24 hours. So you can see on the table it has service components, their viewers and their percentage change, and its comparative analysis of whether the viewership is increasing or decreasing. The live users are presented on the dashboard as a pin on the map. Since we have turned on our internet back, our location will be immediately available on the map in terms of a pin. And if we click on this pin, then this pin will give a pop-up that will contain a detailed information about the specific user, like name and the interested genres, the channel or service currently being watched and the program at that current duration. To conclude, the D2M user statistics are helpful in creating each device or user profile, detailed insight into service program and viewership, and the targeted advertisement delivery tailored for each device. This dashboard is still a work in progress, but once it's complete, it will give us a lot more refined data, helping us understand who is watching what and allowing us to deliver more targeted ads. Content prepositioning is also one of a very important use case. This is something that is currently in development, but we have made a significant progress in terms of developing the underlying library and middleware component of this. Now we are full stream ahead in implementing the use case into the D2M application. So far we have finished the library work. The integration in D2M app is ongoing. The main utility of content preposition is that any file can be transmitted. So we are capable of transmitting and receiving any file into the D2M application. The NRT files that are downloaded can be presented through the browser. In NRT, the content is downloaded in the background. Then the downloaded content is categorized in the app based on context ID. We have a download icon in the application which represents the NRT downloaded content. Content is presented to the user on the device browser. Here you can see the downloaded content. On click, it redirects us to the browser. Since this is an image, it is presented as an image in the browser. This is one image that we also transmitted. We can also send files, video files, and they will be similarly presented to the user in the device browser. If the file is not supported by the browser, something like a generic file, then it will be downloaded in the browser and then other relevant application can access those files directly from the device storage. We also have a cache management in our application where we can see all the metadata that is received for each service, whether they are AV service, audio only, and NRT service. This is something useful in development and initial days of rollout, and while we develop a business case around the content prepositioning. In prepositioning, some of the pending work that is ongoing is the automatic cache management, the filtering of NRT downloaded content based on user statistics and user watch preference, so that only the relevant content is presented to the user based on the user's app usage, again the user statistics and the interests.